Hey everyone. In this session, given we have a mixed audience, I know some of you may be new to Apache Beam, while others may be veterans. I've tried to put a little bit of an intro into Apache Beam before we get into, where we think Apache Beam can be assisted with and be part of this agentic era with event-driven agents. Hopefully, something for everyone. I would note that there's a couple of topics in this talk that are probably more on for the advanced space, just in a couple of areas. However, please note, I've done them at a high level overview so that you can think of them as building blocks for when you want to come to do these things with agents. And there are a lot of great talks either in the 2026 session, which go deep in those subjects, which I mark as advanced, and I'll tell you which one those are as we go through it. And please note, there is an archive of previous years, 5 years of archives of other content where everything I talk about is covered in really good detail. So with that, a little bit of a level setting for those who may be new to Apache Beam. So Apache Beam, it started in the big data era with contributions from Google. Obviously there was the original papers in this space, MapReduce, and then Flume Java, so Flume allowing you to declaratively create pipelines, moving away from procedurally working through the MapReduce pieces, and then Millwheel, another technology used in Google, which helped with the streaming side. So streaming and match together, this technology then became Dataflow. And if you're not familiar with these papers, I highly encourage them as a very interesting read that really kind of like gives you a good grounding in how the systems are working. And of course, this Apache Beam is the SDK. It's the way that you program and develop your pipelines. And then you have different runners. So we have Google Cloud Dataflow, we have Flink, we have Spark. These are runners that run that code for you and allow us to be able to process vast amounts of data in batch. This could be petabytes of files that you're processing in streaming. This could be using thousands of machines to deal with gigabytes per second of quite complex stateful processing. And again, as we show a little bit of syntax and stuff in some of the later slides, I just wanted to run through a very high level of the Python SDK in this case, just so you get a feel for the shape of it. In this case, we're going to start with a batch pipeline. Imagine you have files that are being generated from an online system. There's files that are being generated from systems that deal with brick and mortar stores. And we want to read the information from these files as we're going to do some calculations on the data within them. So the first thing that we would do is P here is the pipeline. And we are beginning to establish the shape of our pipeline by applying transformations to them. So P transform is a parallel transform that you apply to P collections, which P collection is a parallel collection. So in this case, we're using the read from text to read those files. There's also a mapping function to extract some information, which will then be stored in the store sales P collection. We also have the online sales P collection. Now we want to bring these together. So the way that we would do this, and by the way, this pipe operator that you see here essentially means apply. So to the pipeline, we are applying this transform. So we want to bring these together. As these contain the same type of item, we can just call a flatten operation. So this is one of many primitives in the Beam SDK, which allows you to do these kind of operations. So here we're creating a single collection from these two different collections because we want to do some computations afterwards. And now we come to the computation stage. Again, the details of the computation doesn't matter, but essentially it's doing some aggregations and doing a calculation for us, which we then want to output. So for the output, we will send it to our sink. So at the top, we had our sources, which were these files. At the bottom, we had this sink, which in this case goes to BigQuery. Now, the nice thing about Apache Beam is it unified the ability to do batch and stream processing within the same SDK, and without having to adjust your business logic. So here we see the business logic in this section here. What do we need to do to this whole pipeline to move from batch processing to stream processing? Well, very little. First of all, we change the sources. So from now, rather than reading files, we are reading from PubSub. and creating these P collections. These are, of course, real-time collections. So this is a stream of information that is being processed. So the other thing we need to add is a window function. Here, we basically partition this P collection up based on time, and we are now, this pipeline would continuously output information based off of windows of every 10 seconds. Okay, so hopefully you get a little bit of a feel for this syntax, because we're going to be seeing that in the coming slides. Now, around where we think Beam can be helped by and be useful in with event-driven agents. First of all, there's a couple of things that we need to think about as we figure out what are the right set of use cases to bring together these two components. So if we think about, and we're going to be mainly concentrating from streaming from this point on, if we think about a typical stream processing pipeline, it will have a high volume data stream. So, if you had one message per second, in general, you could deal with that with one worker. Therefore, you don't really need the power of Apache Beam's ability to do distributed stream processing. So it tends to be higher volume data streams. It is asynchronous processing. And the reason this is important, as we think about agents and stuff, a lot of agents that we'll encounter are of the type where you, as a user, are interacting directly with the agent. So, you may be asking a question and getting a direct answer back. It's all very synchronous. With our stream processing, what we do when we want an event to be processed within the pipeline, we will send it to Kafka or send it to PubSub or any other event processor messaging system, and then the data flow or the runner of choosing with Apache Beam will process that element and output the result. And that result will then output either to a bounded source like a database, or something like PubSub again, or Kafka, to go onto your other systems. So therefore, this is an asynchronous process that we are concentrating on. And then the other thing about pipeline structure, as we saw when we built out that code with Python, it's a fixed pipeline shape. So we've defined the pipeline. It is set for the duration that process is running. The code that we write within each of these elements is also set. So it's not able to dynamically change or adjust the plan, the type of computations that it's doing based on the data itself. You would have to code that in. So, you may have multiple branches on this tree based on decisions that you are making, or you may have decisions in your code that lives within what we call a do fund, that unit where you're doing your user code. However, we can't dynamically change this and adapt. This is where I think agents become very, very interesting. Because imagine we did have that ability. So imagine that we have an agent, the ability to put an agent in one of these nodes. So as an operation, we have an agent that is doing its own orchestration for its plan. So it's looking at the context it's received and deciding what are the types of things that I need to do with this, using its own solution space of prompts, skills, tools, the things that you've provided to that agent to be able to go and explore the problem. And not only can it decide on its own plan and carry out that plan, it can also loop. So it can try multiple times to actually get to the solution that it wants. Now, you'll note that I have a arrow from a filter in this pipeline structure. So why are we filtering, and why are we only sending some values to the agent and not all values to the agent? And particularly the marking here, high value events. So the reason for this is, in general, what you'll find with an agent when it's doing some processing, especially when it's doing things like loops and calling other APIs, etc., it's going to take some time to process. So it might take tens of seconds, might even take minutes to do the processing that it needs before it returns a result. So this comes both at a computational time cost, but also at a pure cost in terms of resources. Now, so what you want to tend to do, we believe you were going to want to do, is filter your results. So things that are of lower return on investments, or lower ROI, lower value to your business, you want to deal with in the standard pipeline. And then only very high value items send to the agent. Uh, to illustrate some of this, I got some examples of things. For example, imagine an agent that is enhancing your recommendation system. So let's imagine there's a pipeline that, as you give recommendations to people on what they should purchase, it processes that data and sends it on downstream for future use. But it notices that Reza has rejected 10 things or 20 things, or the number is arbitrary, but Reza has rejected the last 10 recommendations. It may be that at this point your filter is, if count is bigger than 10, send to the agent, and then the agent may do things like explore stock levels, look at past purchases, maybe Reza's interest in mountain bikes or camping, look at the abandoned carts, and then perhaps put together personalized price bundle ready for Reza to see if now I would like to purchase that item. Imagine an intelligent support system. So you have support tickets being processed through your streaming pipeline and continuously updating your operational systems. One of the filters may be a sentiment analysis. So you have a small model that's looking to see if the user is getting frustrated and is starting to become negative in the responses. So there you may then want to send that negative event to the agent so it can maybe look at more system data, summarize tickets, create a new remediation plan, and pass that and escalate on to the right department so we can make that person happy again. Finally, there could be an agent that is in the financial space and you're looking for fraud. Now, the upstream filter here may be anomaly. Now, one of the interesting things about anomalies is quite often anomaly systems will find anomalies, but will sometimes have what are called false positives. In other words, the system may think it's an anomaly, but it's actually normal. Now, the thing about false positives is they are quite expensive. They go to a person to get resolution, and therefore that is quite a large expense for a business. So maybe when we get a positive, we then first send that positive to an agent so that the agent can gather more history, look at analyze patterns, and perhaps reassess the score and say, yes, I think this is a fraud, and pass that on. So these were some examples of how we want to use some filtering, and then the kind of things an agent can do and adapt to when it's in the pipeline. So let's think about what are the things where Apache Beam can help ensure the agent gets the right things it needs to do what we want it to do from the business point of view. And something that does help us a great deal in this space comes from the work that the community did in developing Beam ML. After Apache Beam was introduced, ML became very important for most people. They started doing a lot of streaming and batch pipelines were doing ML work, some in the pre-work space in terms of training, but also in the inference space where we are, using the models that are built to do smart things with the data. Now, one of the things that's interesting about the ML space was we found that many customers are doing similar things, generic things, and each customer is having to do that thing by themselves over and over again. A simple example of this is inference. So a common thing is I want to pass this piece of data to a model, and I want to get the inference to make use of that. Now, that simple act, when you want to productionize it, is a lot of work. First, you need to ensure the model gets loaded correctly, perhaps have the model as a singleton within the worker because of memory constraints, make use of the GPU effectively, do things like batching, good error handling, etc. Things that every single customer before BeamML had to do themselves using our core primitives, these building blocks to get to their goal. But what we developed was, as a community, the turnkey transforms. So what a turnkey transform is, and the first one was inference, actually it's called run inference, is a single line of code that you add to your pipeline. And as a developer, you pass in configuration. For example, you pass in where the model is or what kind of model you want to make use of. And then that simple line of code underneath is obviously thousands of lines of code where that model is efficiently being loaded onto the system, and all of the things that we described before are being taken care of for you as a user. This makes writing the pipeline much simpler, and means that people don't need to repeat things over and over again. Now, there are many turnkey transforms that were developed, and they are particularly well suited for this agent space, as we'll see in a moment. So, what are the kind of things that we would want our agent to have in our system? So, one of the things that is useful is having the right context. So, we know that passing the correct context, the correct information to the agent, um, is the best way for that agent to be able to best answer our query, or best make a plan for the things that it needs to do to be able to solve our problem. Now, context comes in several areas. So it could be historic context. For example, taking Reza as a shopper example, it may be that it's useful to have the historic context of where what Reza's been purchasing, I've been purchasing in the past 3 months. Maybe camping gear, maybe some mountain biking gear. Another area is the in-stream data. So while it's useful that I've been doing, knowing that I buy camping gear, it may, what we want to see is today or in the last hour, Reza has been looking not only at mountain bikes, but specifically at the mountain bike forks. That is obviously an area that I'm interested in. So we need that in-stream information as well as the historic information to provide the right context to the model. Finally, the external data. So this is where you want things like, for example, fork manuals to be brought up. And for this, we'll make use of, we may need to use RAG. And on the other side, in terms of the agent itself, we want an agent to be available in the system, ready to take these events and drive its application. And a slightly more advanced case, we may want that agent to have some history of previous conversations to do with this session. So how does Apache Beam's turnkey transforms help in this space? So for historic information, and this is one of those areas I said at the beginning where if you're new to Beam, there are other talks which go in depth on each one of these things that I'm touching on, but just broadly as to what it does. And we have the enrichment transform, which allows you to attach information. So if you've got event like Reza is the key, attach that information from a key value store like Bigtable to Reza in a very easy way with this turnkey transform enrichment, with the config being passed in as to where the Bigtable is and what key to match. With this, that the data that I already have is now added with historic information. Next, we may want the in-stream information, so the things that I'm doing right now. Now, with that information, it may be they just use the core primitives that are available in Beam. You may use the do fund to, for example, extract pieces of information from the JSON object. You may use group by key, or you may even use very advanced features like state and timers and the ordered list state. And there are also talks on all of those things. Those become particularly interesting in time series, where you're trying to extract features from time series for the context. Once we've got these features and we've got the historic data, finally, we may want to use RAG. And again, this is an advanced topic, but essentially taking information, creating the embeddings and calling the cosine similarity on vector to pull in things like, for example, the manuals, the right manuals for the fork or information around those forks from our information. With this, we have quite a comprehensive set of context that we can pass on to the agent. Now, the bit about actually, so how do we pass this on to the agent? Well, in 2.73, which is just about to release, there's going to be some integrations with the agent development kit. Very similar in style to how we do with things around inference. Essentially, you're going to you can build an agent within with the ADK. Then you can package that agent up, and the agent object is then passed into one of our turnkey transforms. What this allows you to do is that context now is passed to an agent, which is ready in within the worker once the job was started. And once the message is sent to the agent, it will go through its processing and output the results for consumption downstream. Another area that is being added in 2.73, and again, this is, I would say, quite advanced topic. So, please dig into it as if you find this interesting once the release is done. But essentially, in general, we would imagine that most of the use cases are where that context is sent onto the agent, and that history of that particular conversation with the agent is no longer needed after that. So the next event that comes in, the context is fresh and everything is new. However, there may be more advanced use cases where you may want to have a history of the conversation. For example, if there is a problem if it's a support problem with some services and the service has gone down, you may want some of that history retained, or other use cases like that. For that, there will be the ability to make use of different session services along with the agent itself. So, in summary, agents, I think, are going to add a powerful tool for us to be able to really change the way our pipelines are created, giving us a nice dynamic, adaptive element to these pipelines. With Beam, the real-time context we saw how we can add history, we can extract features from the in-stream information, and also be able to make use of RAG using the inbuilt turnkey transforms. And with our ADK integration, you're going to have an easy declarative way of incorporating all of this into the pipeline. What's next? We're going to look at how we can, potentially add the ability to make it easier to use locally hosted models like Gemma within workers. Thank you very much.